today's video, we're going to be talking about differentiation of a sum or difference. The differential coefficients of a sum or difference is the sum or difference of the differential coefficient of the separate terms. Thus, differentiate the sum or difference term by term. In a nutshell, what they simply mean is that if a function is given to you containing multiple terms, to find the derivative of such function, differentiate each of the terms separately, or differentiate the terms by term. But before we start to look at how probably we can do such differentiation, I would like us to know that the first derivative, dy dx, if y is a function of x, then given a function f of x which is also a function of x, finding the first derivative of such function will also be written as f prime x, and this is also written as d dx of f of x. That's according to our previous video, right? So noting this, if I'm having a function f of x with a different function which is g of x, and these are separate terms, the addition sign is in between these two functions, then probably another function h of x, right? And I want to find I want to differentiate this function. Then I'm going to apply the dx to the dx to the function this way. But as what we read earlier on says, we should differentiate the sum or the difference term by term. Because of that, you're going to apply the d dx to each of these, the terms in the bracket. There are how many? 3. 1, 2, 3. Each of these terms separately. So we're going to have d dx of what? F of x. Okay. Then plus d dx of v of x. Okay, then the next one is minus d dx of h of x. Okay, so having done this, let us take an example to demonstrate or to appreciate the addition or subtraction, or probably the summation and the difference of what? Differential functions. Examples. One. If y is equal to 3x squared plus x raised to the power 5 plus 4x, okay, plus 4x, find dy dx. Solution. So as we said earlier on, the dy dx is going to be the derivative of each of these things. Okay, so we take d dx of what? 3x squared plus d dx of x raised to the power 5, then plus what? D dx of 4x. Okay, now the dy dx is going to be the derivative of 3x squared. As we've said in the previous video, we're going to multiply the power by the coefficient of this x, so we're going to have 2 times 3, then we decrease the exponent by what? 1, and our exponent is 2, we decrease it by 1, then plus the next thing, you multiply the whole of this thing by 5, so it is 5 times what? 5x, right? It's 5x, multiply 5 by the x raised to the power 5, but we're going to decrease the exponent by what? 1, okay? And then we also have, let me write the one word by 1, and then plus 4x. The 4x, the exponent of this x is what? 1. So actually we're going to have 1 times 4, okay, then x. We're going to decrease this exponent by 1. It is 1 minus what? 1. Okay, so the x dy dx is going to be 2 times 3, that will give us what? 6. Then x raised to the power 2 minus 1 is going to give us what? 1. And x raised to the power 1, you can decide which to write a 1. Okay, yeah. Then here we have 5x, okay, raised to the power 5 minus 1, that's going to be what? 4. Okay, then plus 1 times 4 is going to give us 4. Then x raised to the power 1 minus 1 is what? Is 0. Okay, but x raised to the power 0 is equal to 1. And when you multiply the 1 by 4, you're going to get what? 4. So simply, that is how we can differentiate, or how you find the first derivative of y is equal to 3x squared plus x raised to the power 5 plus 4x. Let's take another example. Okay, so in this example, let's do right. Example 2. If y is equal to 1 and 2 x raised to the power 4, let me go here, x raised to the power 4 plus 4x raised to the power 3 minus 3x raised to the power 2. Find dy dx. Okay, so solution. Just as we did for the example 1, dy dx, we're going to take the derivative of each of these terms separately. We have 3 terms, which is 1, 2, and 3, right? So we're going to find the dx of half x raised to the power 4, then plus d dx of 4x raised to the power 3 minus d dx of 1 of this term, which is 3x raised to the power 2. Then we do the computation dy dx. So to take the derivative of this term, we're going to multiply the coefficient of this x by what? 4. So we have 4, and already we have half there, right? Then we have our x, and we decrease the power of the x by 1. Should we do it straightforward? Yeah, so 4 minus 1 is going to be what? 3. Okay. Then the next one, we're going to multiply the 3 by what? The coefficient of this x. I think we should go straightforward, right? So we're going to multiply 3 by 4. That is going to give us what? 12. And we decrease the exponent of x by 1. So we have 3 minus 1. That is going to give us what? 2. Then minus. Here, we're going to multiply this exponent, the 2, by the coefficient of the x squared, which is 3. So 2 times 3 is what? 6, right? Times 6x. Then we decrease the exponent by what? 1. And then 2 minus 1 is what? 1. And when the exponent is 1, you can decide how to write it. This one, we can simplify that, right? So we have the x. dy dx is going to give us 4 times half will give us what? 2x cubed plus what? 12x squared minus what? 6x. And note, these are not like terms. The power of this x is what? 3. The power of this x is 2, and the power of this x is 1. Because of that, you cannot simplify any further. Okay, right. Let's take the last example on this, right? 3. If y is equal to 5x squared minus 4x plus 9 minus half x squared. Okay, half x squared. And we comma. Find y dy dx. Okay, so solution. And we said the dy dx is the derivative, the first derivative of the function. So we're going to have dy dx. And this time around, I don't want us to write the d dx of the terms as we've done in the previous ones. We know that by this time, we know we're just going to take the derivative of each of the terms separately. So we take the derivative of this. After that, we take the derivative of that, we take the derivative of this, and we take the derivative of this one too, right? So the derivative of the 5x squared, we're just going to multiply the exponent of this x, the 2, by the 5, and it is going to give us what? 10. Okay, 10. Then I write my x, and we decrease the exponent by 1, or we subtract 1 from what? The exponent. And 2 minus 1 is going to give us what? 1. So currently this x is raised to the power 1. So we're done with it. We go to the next thing. And the next thing we have what? We have x minus 4x. So I bring my negative sign, right? And then I'm going to multiply the exponent of this x by the coefficient of the x. The exponent of this x is what? 1. So when I multiply the 1 by the minus 4, what do I get? I get minus 4. Okay, get minus 4. but you're going to decrease the exponent by 1. We're going to decrease the exponent of the 4x minus 4x by 1. Now it is 1. When we subtract 1 from it, it's going to be what? 0. So it will be x raised to the power 0. But x raised to the power 0, as we know already, is what? It's 1, right? So when you multiply the 1 by 4, or the minus 4, you're going to get minus 4. So that's all for that, right? Then the next term, we have plus what? Next term is plus 9. And in our previous video, before we did dealt with that, we said the derivative of any constant, now it's a constant of any constant, is what? 0. So straightforward. So I'm just going to write 0. Okay. And the next term we had minus. We're having minus half x squared. So we're going to bring a negative sign, and then half. Yeah, so the exponent of this x is what? The exponent of the x is 2. So we're going to multiply these two by the coefficient of the x squared. So it's going to be 2 times half x. And then we will subtract 1, or we're going to decrease the exponent by 1. Okay, so 2 minus 1 is going to give us what? 1. So we're going to have x, because x is already raised to the power 1. So in a nutshell, we're going to have dy dx will be 10x minus 4. You know, the 0 minus 4 plus 0 is minus 4, and we can simplify this. This is going to give us what? Minus x. Minus 2 times 1 over 2 is going to give us minus 1. Then the minus 1 times x is going to give us minus x, right? You can simplify this further, because the 10x and the minus x, they are like terms. You can simplify it. So the dy dx is going to be 10x minus x. That will give us what? 9x, then minus 1, 4. So simply, that is how you can find the differentiation of a sum or a difference.